Alright, so today we're going to talk about volts, current, resistance. Alright, so first up we got volts. Alright, so volts is basically the electrical potential between 2 points. So to measure volts, you got to know what kind of volts you have. There's two different types of volts. There's DC, which means direct current, and then AC, which means alternating current. Those are the two types of volts you have. DC, direct current, means you just got a steady constant voltage, and it's just a solid flat line. So you just, if you got a 5-volt supply, then you just have 5 volts constantly. With alternating current, you do not have a steady constant supply. You have a wave of voltage, and there's different types of waves you can have, but the type of AC that you're gonna typically recognize is the output from your outlet in your home. So you got your plug-in, which is 120 volts AC. So that means alternating current, and then so your voltage output from that would look like this out of your home outlet, saying this is 0 volts, and then your voltage is just constantly going up and down like that. And there's a reason behind that. I'll get into that in a different episode. But volts DC, let's say this is 0 volts, and you got a 5-volt supply. Your voltage is just going to be constant, 5 volts. So DC voltage would be a battery. So just to show you, got a 9-volt battery here, and I switched my meter to volts DC, which the symbol for that is solid line with a dotted line underneath. That's volts DC, and then the volts AC would be a V with a squiggly. And then on my meter it shows that, but that just means that you can hit the red button, because the hertz is in red, so you can hit the red button and get your frequency, which we will get into that part on a different episode. So we're going to measure this battery and just see that your negative is the big round one, and your positive is your little round one, and there you got 9.35 volts. And you can see on my meter down here that this plug is for the voltage, and then you can measure ohms, capacitance, and hertz there too, but it's marked red for your positive side. Then your common there, which is marked black right there for your negative. And then it gives you voltage ratings down here too and what your meter can handle. But so there is a DC voltage, just a constant 9.35. And I'm going to talk about volts AC in more depth later, but for these examples today we're just going to use volts DC. Volts is just the electrical potential between 2 points, and then when you when you connect the a circuit between those 2 points, let's say you could just put a jumper wire across the two points, or you could put a resistor across it, and at that point you'd be completing a circuit between the 2 points, and then at that point you would have what's called current. So you'd have current going between the positive and negative, which is basically just the flow of electrons between point A and point B. So that's what current is. And if you have anything that slows down the current in that circuit, that would be called resistance. So basically a resistor. I got a resistor right here on my breadboard. It's a 1000 ohm resistor. It's all black, but I know it's 1000 ohms because it says it's just marked that. So let's just show you an example. So that's a 1000 ohm resistor. Switch my voltmeter over here to the ohm symbol. So resistance is measured in ohms, and the symbol for that is right there. And just like volts has a symbol, the volts DC is or in schematics you'll just see a big V with a DC next to it. Either case, same thing. So let's just measure the resistance of that resistor. And there you go. It's just right on the edge of 1000 ohms, so it's bouncing a little bit back and forth. Plus this meter is old and it's not the most accurate. So there you go, there's 1000 ohms. And as you can see, this is an auto. It automatically changes its range, so it's in kilo ohms right now, so it's 1.0 kilo ohms. And I made another video explaining what the kilo means if you want to look that up. It's the prefixes of the values. So that's resistance. Resists the flow of current. So let's just make a circuit here and show you what the flow of current looks like. So current, which is measured in amps, and then the symbol for that is A. So on my meter here, I'm going to go over to, in this case I'm just going to be drawing milliamps, so right there's milliamps, and I need to switch my meter over in order to measure that to the milliamps hole. And that's because current is measured different than voltage. Voltage, you go in parallel across the part or whatever it is you want to measure the voltage, but current you need to go in line with the circuit. You need to break the circuit and be in series with it. So let's just see what our battery is at currently, and we'll write that down. Okay, it's at, so our battery's at 9.33 volts DC, and we got our 1 kilo kilo ohm resistor that we're using in the circuit. Let's just see how much current it draws. So let's switch it over to the milliamps, and then I'll show you how to hook it up here. So I got that switched over to milliamps. So we'll put one side to the battery, the other side of the battery over to the resistor, and then from the resistor back to the, so 9.31 milliamps. So that's we just completed a circuit there with a resistor. So we're going through this jumper into the resistor, out of the resistor, into the meter, out of the meter, and then back to the battery. So it's making a complete loop here. And to just show you what it would look like on a schematic, I got this symbol here for the battery. You got your positive on this side, negative, and that's 9 volt, and then it's going through the amp meter and then going through the resistor and completing the circuit. So that's what we have going on here. So as you can see, it just continues to drop, but that's because it's slowly draining that battery, because you got the electrons flowing and you're draining that battery, so it's going to continue to drop. So there's the symbol for a resistor. It's just a jagged line there. This is the symbol for an amp meter. So, and this is the symbol for a battery. And by the way, if you leave it hooked up as an amp meter, and then you go to measure voltage with it, you will blow a fuse inside your meter, and you'll have to change it. So you can see down here, this says fused, and then that's because you're just basically shorting across the whatever voltage source you have there, and whatever maximum current it can put out, it will cross that fuse and blow it.